Okay, so what is Blackfire? Maybe the first thing I can say is, I'm going to be very quick on telling you what is Blackfire, how it works. What I really recommend you, if you want to know more, is really go to our documentation site as much as possible. We try to have all information available there, and that you can find your way quickly.
I'm sorry, are you sharing the screen now or no?
I will be sharing the screen in a second. Yes. Thank you for the reminder.
Okay.
All right, here it goes. Everybody sees it now? Good. Yeah. All right.
Yes.
So yes, as I mentioned, please go to the documentation site because you will find all of the information there. We try to make it, as thorough as possible. Now, let me give you a quick walkthrough. So Blackfire is all about performance management of PHP code, right? So the idea is to give a developer all of the metrics he needs to understand how his code is behaving and how to make it faster, essentially. We are very different at this point from a category of tools that are named application performance monitoring tools, one of the big brands out there on the market being New Relic. Because of a real simple reason. Whenever you measure some code performance or behavior, you actually need to execute some more code. You need to execute the Blackfire code that comes on top of your own code. That's called the instrumentation. And instrumentation generates an overhead, right? Because you execute some code, you're actually consuming some server resources in the same time than your code is actually doing it. So from here, you have two different ways to work on it. Either you instrument real end-user requests, or you don't. And in the case of a monitoring tool, you actually want to instrument those end-user requests, right? You want to actually monitor how traffic is going, how it is performing. So you are by then limited on the quantity of data that you can acquire, because the more data you acquire, the higher the overhead is going to be. That's really unavoidable, unfortunately. So the point of New Relic is to monitor the traffic and then to provide you with high-level performance metrics. But it's not going to tell you really how the code is behaving, right? It's going to give you a few pointers. Maybe it's enough for you. But what Blackfire is doing is it goes much deeper down into the code. And our choice has been to never instrument end user requests. So how Blackfire works is that you, as a developer, will decide, I want to start profiling this specific part of the code. And that's going to be for a request that is going to be triggered by the tool and never on an end user request. So there's going to be no overhead at all produced by Blackfire. Okay, let me give you then a quick example, as this is now hopefully clear. This is a PHP application. It's actually a web UI for Git. It's Gitlist. It's an open source application you can find on GitHub. And let's imagine we're in a situation where somebody told me, well, your site is slow. That page, it takes forever to load. Or maybe a tool is telling me that. Actually, it could be an APM that is telling me that. So what I'm going to do now is, okay, I want to understand how the code behaves. I'm going to have to measure how it behaves exactly. For this, I can use Blackfire, either by starting a profile while browsing on the app and using the Chrome or Firefox extension, or I can actually do exactly the same by using the command line, where we have a curl wrapper, so that clicking on that button or typing Blackfire curl is going to be the exact same thing. The great part of the browser extension is that it's very user-friendly. The great part of the command line is, of course, it gives you a lot of flexibility on how you, what you want to profile. You can profile some GET requests, some POST requests, whatever you want. You can also do Blackfire run, which is then going to be profiling some daemons, crons, PHP scripts, you name it. Okay, let's now stick to clicking on that beautiful red button. So what happens here is, as you can see, it takes a bit of time to do the actual profiling. That's simply because we actually did 10 profiles in a row. We did 10 samples of profiling so that we could average and aggregate the data, and in order to make it more reliable. So the idea is really, if I do another measurement, you can see here it took 162 milliseconds. If I do the same measurement again, it should be very close to the 162 milliseconds, unless, of course, something is happening on my server at that moment. So talking about those 162 milliseconds, that's where we start breaking down the information. So this is the actual wall time, which is the overall PHP execution time, right? It's the moment it's the time between the moment we start executing the code till the moment we stop executing the code. This is broken down into input-output time. So it's time that the CPU has been waiting for some input or output, which can be, I don't know, network, memory access, whatever, you name it. Then there is the CPU actually working. So CPU plus IO give you the wall time. Then you have memory usage. And depending on the code, if there is some, you're going to have the network, HTTP requests, and SQL queries. For now, let's have a first look at what we call the call graph. The call graph is actually a graph that shows all of the function calls that have been executed in the code. And it shows this as a graph, as a tree, where you start from main until you execute all the function calls. The idea is that the color codes is going to tell you very quickly where you're spending most of the resources. You actually have two ways of looking at it. You can look at it from the inclusive time perspective or the exclusive time perspective. Inclusive time is the time spent within a given function plus everything it has been calling. So main is responsible for 162 milliseconds from the inclusive time perspective. Now, from the exclusive time perspective, which is only the time spent within that function, forgetting about the rest, it's here totally insignificant. So inclusive time is highlighted with all of the nodes that have a brighter border. So you can see here the hot paths in the application. And then exclusive time is going to be highlighted with the brighter background. So here I can see that stream select here is responsible for more than half of the 162 milliseconds. Just before I tell you actually how we're going to try to fix the code, I can also show you the fact that on all dimensions, you will have also the same type of call graph. So maybe it's a matter of time, maybe it's a matter of a subcategory of the wall time, maybe it's a matter of memory. That's the same. With all of those graphs, you will be able to figure out exactly how you consume resources and what you can potentially do about it. When it comes to SQL queries, well, even if I don't have some in this code, you will get the list of all of the SQL queries with the number of calls and the time spent within each query with the details about it. There is another visualization which is worthwhile, which is the timeline. The timeline is roughly the same profiling information that we gathered, but then we display it as a time sequence, again, from the moment that the code starts being executed till the end. And then with the blue curve here, which is the memory usage, and then all of the calls, which are stacked here. So depending on what's the issue you're facing, what you're looking for, both views are actually very complementary. Let's switch back to the call graph for now and the wall time. So I mentioned, okay, here, stream select is consuming more than half of my time. So that's where I have my bottleneck. Now, how to read a call graph is to understand exactly what you can do. So what is actually actionable, right? Stream select is a PHP function. That's not something that you're gonna try to optimize. What you should be wondering is how come that you have been doing about 80 calls to stream select. Maybe that's actually the area where you can act, something that you can change in your code so that there is less calls here. So the idea is to climb up in the call graph in order to figure out where is your code, how did your code start triggering this. And here, climbing up, I find those two calls here, get lists client run and get lists client get version. So again, my app is WebUI for Git. And here, actually, the get version function in my code, this is essentially getting the value of the Git version. And having my client run do 10 calls to this doesn't make any sense, because that's the kind of value that is never going to change during a single page load. So potentially what I can do in my code is cache the value, right? Do only one call here, and potentially I'm going to spare 9 times whatever is executed down here. Let's imagine I do the fix. It's actually already done. Good. It's, I'm quite lucky. So this is the new code where I cache the value, and hopefully I'm actually sparing some time. Now, again, what's important is that you measure what is the impact of your changes. If you don't measure, you don't know. Maybe that change is great. Maybe it's actually killing your performance. So let's measure again and see how it goes. So this takes, again, a couple of seconds. Now, what I should do is, I can, of course, go and look at the overall value here. It looks like we did spare some time. I can also look at the timeline and the call graph, but something is going to be much more powerful in Blackfire, and that's going to be a comparison feature. Basically here, this was the profile I did 7 minutes ago. This is the new profile, and well, I'm going to ask Blackfire to do a comparison. So it's essentially a matter of, subtracting one profile from another and then showing again the results in a call graph. Everything that is in blue is a performance improvement. If there would be a regression, it would be shown in red. So we can see indeed 30% less time. And yeah, definitely the usage of stream select improved. And if I go on the number of goals to get version, that also improved a lot. So this is really the idea again. When you have a performance issue, you need to measure exactly what is happening. And when you try a fix, measure again, because you need to validate what's happening. I don't know if I have a bit more time left, Tanya.
Yep, you have like 3-4 minutes.
Okay, so this was about on-demand profiling. We have been using the browser extension. We could have been using the command line. The thing is, we still had to do something ourselves to get the information. What's also going to be very powerful in Blackfire is to automate that. Let Blackfire profile your code on specific events at specific moments where you want to have more insight on how the code is behaving and how it is performing. And for doing that, we have built some really powerful tools and hopefully simple tools. One of them being the Blackfire Player, which is a tool that we actually open sourced. It's a tool which is something a bit like Bhat. It's a web crawler, tester, and scraper, which basically will enable you to run a lot of different tests on your code, and at the same time to start profiles with Blackfire. So the whole idea is that you will be able to script entire scenarios, saying, for instance, I have a visitor that comes to my site, visits the pricing page, logs in, subscribes, all of those steps you will be able to simulate with the Blackfire Player. And every time it's going to trigger a PHP request, the Blackfire profiler is going to profile it, so that at the end, you will end up with a full report of what is going on in your application. We call this a build report, where one of the other things that you will be able to parameter is actual tests. So here, I mentioned how you can run scenarios and simulate a user behavior. Now, for each step of those scenarios, you will want, of course, to set a performance budget. You will want to set, okay, what are my expectations? How should my code perform? I wanted, for instance, to load in less than 50 milliseconds. I wanted to use less than 2 megabytes of data. And actually, those tests, especially the wall time here, is probably going to be one of the weakest tests. a test on time is something that is not reliable, because on production, time is especially on production is something very volatile, right? The wall time is going to vary depending on the server load. So it can be that at one point, if nobody is using your site at that moment, you start a profiling session. Well, that test is green, and then 5 minutes later, 100 users connect. You start having some server load, and then the wall time is going to increase. Now the test is red, and well, you don't know much better what's going on. It was green before, now it's red. What should you do? So the idea is going to be to then write tests which are going to be much more focused on the actual code behavior. So for instance, here we're checking the number of twig displays. So we know here, if that test is failing, we have a very good clue of what's going on, what we should look for in order to improve the overall performance. Actually, we even wrote some default tests, which we call the recommendations, which are going to detect without you having to write anything more than the scenarios. So telling Blackfire basically what it should profile on your site. We will be able to tell you straight up if there are things that are going wrong in your code. And we can do that on performance, but we can also do that on security and quality. Indeed, Blackfire is a provider, and its point is really to, again, look at everything that is executed in your code. The first reason to use it is performance, but actually, again, it looks at the code behavior. So it can do a lot more than that, and it can go have a look at the performance and the security and the quality of your code as well. And yeah, finally, once you have those build reports, it's also cool that you can decide when they start. So we have a lot of different integrations so that you can say, for instance, whenever I deploy somewhere my code, I want to run those scenarios. And of course, once the build report is available, I want to get a notification where it matters to me. Emails that nobody reads, Slack channels that are always totally crowded. But really cool ones are GitHub, Bitbucket, and GitLab. If you have the whole tool chain that is going to enable you to deploy each Git branch at every code commit. It's not always the case, but nowadays there's a couple of cool platforms that enable to do that, and then it becomes possible.
Hey, thank you. We already have questions, and I see Alexander Makaro. Sasha?
Yeah, hello. Thank you, Christoph, for the available information. That was very interesting. And last time I was digging into the Blackfire, it was way less features, actually. It was a long time ago. So the question is about the tariffs. I know that there is a hack edition.
That's correct.
Yeah, but I want to ask about the open source. Do you have some special tariffs for the open source projects or something like that?
We do support some open source projects. Now, we really want to do it in an extensive way. So for us, granting for instance, a free subscription to somebody, it doesn't make sense. Usually it's going to be like either somebody is actually going to use it for commercial purposes. They're going to be cheating about it, and of course that's not really cool for us. Either we're going to give that to an open source project who is actually not going to be using Blackfire at all. So we do support some open source project, but then it's usually, when we get somebody coming to us and asking for the question, we review what's the project, and then we work with them. So somebody like Jérôme is actually going to be spending time with them to really make sure that they understand exactly what Blackfire is, how they can use it, and how they can benefit from it. What we really want is each time that we select an open source project, there can be a success story behind, both for the project and of course for us, because yes, at the end of the day, we don't make people pay, but it's of course great if we can do some great marketing from it.
That's even better. Thank you.
All right.
The next question was from the chat. When is the estimated release date for Ruby and Node profiles?
Oh, wow. That's a question I get more and more often. Well, I wish I could give you a date. What I can tell you is that we have started actively working on Ruby. So I didn't tell you that because it's secret, right? But I'm telling it anyway. Node is definitely on our radar. We haven't started yet. It's a little more complex. So recently we added the Python support for us, because of the semantics of Python. It made things not so complicated to support Python. We just released Go support. Semantics of the code, the Go code compared to Python and PHP is rather different. So it was a bit more of an effort. There's still a lot of features that we want to develop on that. Node.js is going to be again, a step further in terms of interpretation of the code and how we can properly display it so that, you all can really benefit from it. So still, we have indeed some pre-registration pages for this, such as it's gonna have to be. Let me check. Hello, yeah, Node.js. Oh, you now are seeing another one that I'm going to tell about very quickly. Just drop your email here. As soon as we have more information, we will tell you. We want to do it, but we have to prioritize things, especially as the next big thing that is coming is an actual APM. So on top of the profiler, if everybody remembers the difference I explained at the beginning of this session, on top of the profiler, we will provide an APM solution as well. And that's the next big step. Hopefully, we will have something available, maybe a beta, by the end of the summer.
Wow, it's pretty fast. Okay, and there was a question from a chat. Can we use it as agent? I'm not sure the context of this question.
Me neither. I'm not sure what it means. Maybe so, Cryptech, if you can clarify what you would like to do.
Yeah. Just mean if I can install this tool on my server and add some configuration file and forget, so I can I think it will be in the APM in the future.
Right. So as a matter of fact, the installation procedure you described is roughly how it goes already. And the cool thing I can already tell you is that if you start using Blackfire today, if you start installing the Blackfire components, there's actually a couple of components here. Let me show you. So that's the overall architecture of Blackfire. If you start using Blackfire as a profiler, on the day that the APM is released, you don't have anything more to install. It's going to be the exact same components, and maybe you will need to update them, but it's going to be just working the same way.
And to add more details here, without talking about the APM, you can also use builds starting from the premium plan. So as long as you define like a few scenarios, like Christophe detailed a bit, you can define periodic builds. So then they will run like hourly. So you can definitely forget about it, and you get alerts if some of your tests are read.
Okay, thank you.
Thank you very much for all the questions. It seems that we don't have any more. Yep. I think it was a fast but really interesting introduction to Blackfire, and for everyone who is not familiar with Blackfire, I would really recommend to try it hands-on. And I'm inviting everyone to the another Zoom conference that the link you have on your email. Join, and we will have a Q&A session with the speakers from the first half of our Today conference day.
Thanks everyone for joining, and thank Christophe and Jerome for introduction.
Thanks everyone for being here and listening to us.
Yeah, see ya.
Thank you,
All right.
everyone. Bye.
Cheers. Bye-bye.
Thank you. Bye.